Okay, what is mean by heat energy in transit? Suppose we have two cup or two bakers. One contain hot water and one contain ice water. And we place both these hot object and cool object, a glass containing hot water and a glass containing ice water. In a room, suppose the room has a temperature, let's suppose 30 degrees centigrade. Now suppose this is hot water, okay, so it means there's temperature, I will suppose it to be 70 degrees C, and this is ice water, so its temperature, inside its temperature will be minus 5 degrees C. Now what will happen to these two systems? If the time is passing, then this system become cooler and cooler, and this system become hotter and hotter. Why this system become cooler and why this system become hotter? The reason is very simple, because we have environment and we have the system. There's the system and there's the environment. The system and the environment has a difference in temperature, temperature difference, because the environment temperature is 30 degrees C and the system temperature is 70 degrees C. So it means that from this system something is going outside to the environment. Something is going outside to the environment, while in this system something is going into the system from the environment. Here something is going from the system to the environment, here something is going from environment to the system, and finally a stage is reached where the temperature of environment, suppose this is system 1, okay, and this is system 2, system 1 and 2. After some time, let's suppose after 30 minutes or 40 minutes or after 1 hour, all the three systems like the environment, system 1 and system 2 approaches to the same temperature. I suppose that after 1 hour, the two systems and the environment has the same temperature. Suppose the environment temperature goes to 29 and the system which was initially hotter now become equals to 29 degree C, and the system which initially contained ice water is now converted into a liquid water, and its temperature is also 29 degrees C. The thing which goes from system 1 to the environment, or the thing which goes from environment to the system, is called heat. It seems that now all the three systems are in thermal equilibrium. So it means that the approaches to thermal equilibrium must involve some part of exchange of energy, because energy is exchanged from system 1 to environment and from environment to system 2. We define that thing is heat and is represented by Q, capital Q, which is defined as heat is energy that flows between a system and its environment by virtue of temperature difference. Between them. Because there was a temperature difference between system 1 and environment and between system 2 and environment. In system 1 the temperature was 70 degrees C while the environment temperature was 30 degrees C. The system 2 temperature minus 5 degrees C while the environment temperature was 30 degrees C. What's happened? There was a temperature difference, so there was a transfer of heat from system 1 to the environment, and there was a transfer of heat from environment to the system, and this transfer was due to temperature difference. And a stage is reached where all the three component of this whole system, like system 1, system 2 and the environment, approaches to the same temperature, and I denoted the same temperature to be 29 degrees C. So it means that something transferred from system to the environment or from environment to the system due to temperature difference, and that thing we call it heat. And heat is basically energy transfer from one system to another system due to change in temperature difference, and the system become in thermal equilibrium once the component of the whole system approaches to the same temperature. Now heat is energy, so it means that we can measure heat in the unit of energy, which is joule, and its symbol is capital J in SI system, okay, system of international unit. But before identifying heat as a form of energy, people use different units. One unit is called calorie, and represented by Cal, and the other unit was British thermal unit, which is represented by BTU. This was the unit when people they didn't recognize that heat is a form of energy. Now we have a relation between calories and joule, between British thermal unit and joule. 1 calorie is equal to 4.186 joule, and 1 British thermal unit is equal to 1055 joule. Like we can say that 1 centimeter or 1 meter is equal to 100 centimeters. Similarly, 1 calorie is equal to 4.186 joule, and 1 British thermal unit is equal to 1055 joule. This was all about heat energy in transit. Now there is another term, there is another definition term which we call it heat capacity. And thermodynamics. What is heat capacity? We will define it here. Heat capacity is defined as the heat energy which we represent by Q, okay, transferred per degree temperature change. Is given the name is called heat capacity. What it means? Suppose we have a system. We have a glass of water. Okay. Its initial temperature is, let's say, 50 degrees C, and we have the room, and the room temperature is 30 degrees C. Now there is a temperature difference between the glass of water and the room temperature. Due to this change in temperature, heat energy transfer from glass to room. Now once heat energy transferred, the temperature of the glass also decreases. If suppose heat is moving from glass of water to room such that the internal temperature of the hot water inside the glass reduced to 49 degrees C, like from 50 degrees C to 49 degrees C. During this change in temperature, the heat transferred from glass to this room, then this heat is called heat capacity, or this transfer of heat is called transfer heat capacity. Heat capacity is normally represented by C prime, which is heat energy transferred per degree change in temperature, delta T, because we have to take the delta T, which is delta T is equal to TF minus TI. Okay, so we will take change in temperature. Now from this equation we see that the unit of heat is joule and the unit of temperature is Kelvin. So the unit of heat capacity is joule per Kelvin. Thank you.